Hello students, today we are going to learn about what is a master slave flip-flop, how it works, and how to develop the master slave flip-flop by the help of a JK latch. By the help of JK latches, I will show you, and I will show you by animation that how to make the circuit diagram. Okay, so coming to the topic, see, first of all, if you don't have the knowledge of this SR latch and JK latch and racing conditions, then I have these two links. This link is showing about how the latches work, and this link is showing about the JK latch and racing condition of JK latch. Okay, so right now I believe that how a JK latch works. Okay, first of all, the master slave flip flop is a cascade of two latches, means one latch and then another latch. The output of one latch is connected to input of another latch. Okay, and by this way this flip flop works. Okay, so see, this is a JK latch, you can see. So these are the four NAND gates. So the output of these right hand side NAND gates are connected to the inputs of this left hand side NAND gates, and J and K are the inputs. J and K are the variables. Any input 0101 we can render, and enable input is also called as clock input. So this is common to both the NAND gates. So it is right now it is 0 for both the NAND gates. Okay. So now what you do, take one more JK latch like this. One JK latch and one more JK latch. Now remove this feedback of left hand side JK latch. So this blue line we can cut down, as well as this red line. So feedback is removed, as well as feedback of this right hand side JK latch you can remove from this input side. So from here you have to trim, and from here you have to trim, and the output of left hand side JK latch is connected to the input of this right hand side JK latch like this. Okay, the feedbacks are removed and then connected. Now what you do, over here there is enable switch. Okay, so for this right hand side latch there is no enable. So what you have to do, you have to connect a wire from this enable, and then connect a NOT gate in series, and then whatever the output of NOT gate, connect to this right hand side system like this. So this is the NOT gate. So in case this enable is 0, since NOT gate inverts it, so the output of NOT gate will be 1, and in case this enable is 1, this will be 0. Okay, now the feedback of this right hand side system is connected to the input of this left hand side system. That's all. This is what master slave flip flop is. Okay, now how it works, see, you can see right now the enable input is 0. So this is 0 for both this these NAND gates AM and CM. Okay, and the J and K are also 0. So 1 is the feedback from this right hand side latch from DS, and 0 is the feedback from this NAND gate BS. Okay, that's it. Now we know this thing that in case for a NAND gate, if any one input is 0, the output is 1. So over here it is 1. So since there are two zeros as input to AM, so output will be 1 of AM. Similarly for CM also, all the three inputs are 0, so output will be 1. So 1 and 1 going inside BM, so it is making 0 because both the inputs are 1, then it will be 0. This 0 is feedback to DM. So in case any one input is 0, then the output will be 1 for an AND gate. So this 1 is feedback of this BM. So 1 1 0 0 1 1. Right now it is in stable condition. Like same you can check out for this right hand side latch also. Okay, now imagine that this J becomes 1, enable becomes 1, and K becomes 0 like this. So in this case what will happen, in case initially En was 0 and J was 0, only the feedback input was 1. Right now J1 and enable 1 and 1 was already there. So what will happen, the output of this AM will be 0 because all the inputs are 1. So when output will be 0, initially output of AM was 1, now it is 0. So when any one input of a NAND gate becomes 0, the output is 1. So this output 1 is going inside DM. Output of CM will not change. The reason being, initially the K was 0 and still the K is 0. So any one input is 0, output remains 1. Okay. So this 1 is coming, 1 and 1 will become 0. So this 0 is the feedback of BM. Okay. So initially the outputs of BM and DM were 0 1, and now by applying these inputs 1 and 0. Now this 1 and 0 is going inside AS and CS of this second latch. These are the two NAND gates. Okay, but it will not change the output of AS and CS. Reason being that this enable is 1. In that case, the enable of this right hand side latch will be 0 because it is a NOT gate. So any one input is 0, output of AS and CS will be 1. So in case outputs of these AS and CS will be 1, there will be no change in BS and DS. Now suppose the enable becomes 0, like this. Now in case enable becomes 0, this NOT gate will output 1, and output of BM and DM were 1 and 0. So 1 and 1 will make 0 of AS. Now when any one input of this BS will be 0, the output will be 1. So that 1 is coming, and the output of CS is 1. So 1 and 1 will make 0. This 0 is the feedback of this BS. Okay, so what we see that in this case, when enable becomes 0 and the input of this latch becomes 1, then initially it was 0 1. Now when this enable becomes 0, this becomes 1. The outputs are 1 and 0. Okay, so this is what a master slave flip flop is. Means in case we want to change the ultimate output, those are Q and Q naught, then enable has to first of all become 1, or clock signal has to 1, and then again become 0. So 1 0 to 1 and 1 to 0, that will make the change at the overall output of this system. So this is called as master slave flip flop. Reason being that this left hand side latch system is acting as a master. So first of all, the change will occur in the master system by changing of 0 to 1 for this enable, and then that change is transferred to the slave when this enable signal again becomes 0, and ultimately we will get the change at the overall output of this slave. So hope by this small lecture you would have understood that what is a master slave flip flop. Thank you.